All right, boys and girls, welcome back to the drive-through. Last video in chapter 3 here. And really, this is just a discussion. There's not a whole lot of math to do in this video. So it says identify the two variables in each situation and determine which is independent and which is dependent. Then determine if the relationship is a function and justify your reasoning. So again, we're just going to kind of discuss this stuff. But one thing that definitely was giving me some caution, or some I just wasn't very sure of, was this versus. So when you hear versus, you could also just think of it with respect to. So you could say a person's name with respect to their Social Security. Which one of those is the dependent variable and which is the independent variable? And in this case, it just depends on which way we write this phrase. So you could say a person's name as a function of their Social Security number is essentially what they're saying there, which means the person's name in this case is dependent on the Social Security number. And so the Social Security number will be the independent variable. So what you have to think about that as is, I could look up somebody's Social Security number, and that Social Security number would point me to their name. Well, since it would only point me to one person's name, and it would point me to the same person's name every time, that is a function. Okay? So what we're going to do is have a little key here. That's going to be the dependent. Is it ant? Dependent. Dependent. This is going to be the independent. Okay? That means it's a function. We can have that in either color. I'll be switching back and forth in colors. And this means it's not a function. And that's how we'll mark each one of these situations. Okay, so a person's Social Security number versus their name. Well, in this case, their name would be the independent variable. So a person's Social Security number as a function of their name. And Social Security number would be the dependent variable. So really, it just depends on how this is written. And if this frustrates you, or your parents, because they're watching, it did me too. So don't worry about it. This part of it is not going to be tested on. But it is important to understand that this is a one-to-one function, meaning for every person's Social Security number, there's exactly one name. And for every person's name, there's exactly one Social Security number, and this is why this one in particular is just a little bit confusing. So it depends on the way it's written, and if you're confused, take out the word versus and write as a function of. And then you'll know that in this case, it's the Social Security number is a function of the name, and therefore the Social Security number is the dependent variable. If I looked up someone's name, it would point me to the same Social Security number every time, and that means it is a function. Okay? All right, hopefully these will start getting a little bit easier. The cost of gas based on the amount of gas pumped. Well, once again, in this one, the amount of gas pumped would be the dependent variable. I'm sorry, the independent variable. The independent variable, and the cost depends. The cost depends on how much gas you pumped. So now, is it a function? Is it a function? Well, I do think it's a function, especially if you're just going into a singular instance. In this point, for every amount of gas you pumped, there is an exact cost. There can't be two different costs. If you pump $10 of gas, you could predict exactly what your cost would be, and that's what makes it a function. Okay, well, this looks like how we typically write ordered pairs, and maybe you never knew this, but you put x into the equation. You can pick whatever x you want, okay? So x is the independent variable. It is a function of x. It's written y equals, f of x. Or maybe in this, I don't know if this is linear or not, I haven't looked. Sometimes it's y equals mx plus b. But what you do in these circumstances is you put in an x and then it pops you out the y. So that makes y the dependent variable. Okay, and it looks like this is a function, and I'm going to erase so you can see. And that's because I never put in a different x value. So the only way it would not be a function is if you saw also a 3, 5. Well, now, earlier in the day I put in a 3 and it popped me out a 6. Later in the day I put in a 3 and it popped me out a 5. If that was the case, and I'm sure we'll get to something like that, it would not be a function. But this one is a function. Whoops. Uh-oh. Come on now. Okay. ViewSonic. All right, the temperature in degrees Fahrenheit with respect to the time of day. All right, well, it's easy to understand that the temperature would be dependent on the time of day, I think, meaning you could expect what the temperature could be based on what time of day it was. The time of day doesn't change because the temperature changes. The temperature changes because it's a time of day. So within a given day, this is indeed a function. If you're looking at different amount of days, then I don't think that would be a function, and I don't want you to get held up on that too much because I thought about that one for a little while. All right, distance and days. Distance and days. I'm trying to take a good look at this one. Let me pause it. Okay, well, it looks like I was just reading into this too much. The book implies, I guess, that this would be, as it typically is, the independent variable. So let's see, that is, nope, wrong color. This side of the column, since it's written this way, depends on this. Meaning this is when we write t-charts, typically we pick whatever we want for this one, and then we see what the output is for the one on the right. Again, just don't worry too much about that. But what is important about this one is that it is not a function. Notice, one time our distance was 6 units and it took us 2 days. And a different time in this scenario, our distance was 6 units, and it gave us 5 days. So our function machine is broken. Okay? The area of the circle as it relates to the radius. The area of a circle is a function of the radius. We could pick any positive radius value, so you could think about the domain of this being only positive real numbers. You can't have a negative radius. And, well, our output, our range, our dependent variable would be the area, and the range would also be positive. And I do believe this is a function. If you pick any radius, it will give you a certain area, and the area won't change at different times. The machine will work, okay? Well, this one I get. It looks like this 3 leads you to 5. So if you put in a 3, it gives you a 5. If you put in a 5, it gives you a 5. If you put in a 7, it gives you a 9. So it's got to be that this column depends, is the dependent variable, on this column. Now maybe you see this 5 and think, oh, the machine's broken because it repeated itself. Not true. The output can repeat itself. Consider this equation, y equals x squared. That's a function of x, just so you know. This is what the graph looks like, and we're going to be learning all about those in this year. But think about it. If you put in a 2, you get a 4. But if you put in a negative 2, you still get a 4. You also get a 4. And that thing itself is still a function too. So this is a function because we have unique input points. The volume of a water dependent on the height of the water. This is very, very dependent on the height of the water. Let's see. Well, the volume of the water, because it also depends not only on the height, but it depends on the radius too. But it's easy to identify that the volume is dependent, we call it, on the height. So we have the height as the independent and the volume as the dependent. And I guess they're assuming that the radius is constant here, and of course then this will be excuse me. Oh man, I feel terrible right now. This will be a function, and I'm going to speed up before I do a live vomit feed here. The size of the radius of a circle dependent on the area. Again, I'm going to have to think about this. Well, based on what I thought of before, I do believe this is a function. So I think maybe you understand that now it's dependent on the area, so it's getting easier. Let's go back. I forget what my key is. So blue is dependent, purple is independent. Blue is dependent, purple is independent. So in this case, we could pick any area we wanted as long as that area was positive. So the area would be the independent. It's got a certain domain that we can pick, and the size of the radius would be dependent on how big that circle is. And for every area we pick, there is a unique radius that goes with that. Students' letter grade dependent on the percent earned. So, again, easy to pick out dependent and independent. We can pick any percent that is between 0 and 100. And this machine will pop us out a letter grade. Oops, didn't change colors for me. It will pop us out a letter grade. So the letter grade is dependent on the percent. And I think if we put it in 88.8, it would pop us out a B. If later on in the day, if we put it in 88.8, it would still pop us out a B. So that is a function. The length of fence needed with respect to the amount of rectangular area to be enclosed. Well, here the length of fence is dependent on the amount of area, and this is a function. Let me think about that. Hold on. I'd like to change my vote. Not a function. Let me explain why. Okay? I was thinking about it the other way. If the length of fence is dependent on the area, well, let's say I pick an area of of 16. So my area is 16. Well, what if it was 4 by 4? Okay, what would be the length of fence? So the area of this is 16 square units, 4 times 4. And the perimeter, the amount of fence, would be, well, 16, which is kind of weird. It doesn't happen very often. So that would be 16 units. 4 plus 4 plus 4 plus 4 is 16. Now, what if my area was 16, but my rectangle was 16 by 1? Again, the area of this is still 16 square units, but now my perimeter is 16 plus 16 plus 1 plus 1. It's 34. I need like literally more than twice as much fence. So for the same area, we need a different amount of fencing. So our machine is not consistent, and then it is not a function. The explicit formula for the recursive situation: f of 1 is 3, and f of n plus 1, I think they meant to say f of n is f of n plus 1 plus 4. But I guess we could maybe figure that out, but this to me just looks like this. The first one is 3. Let's just skip this because the notation is backwards to hell. I don't even feel like confusing you guys. Just skip 13. Let's go on to 14. If x is irrational, f of x is 1. If x is irrational, then f of x is 0. I'm thinking we finally... Let's see. It's the independent. Okay, we have to, let's see. So I think this is a different situation completely. Okay, I think our independent, well, I'll do it in colors. I think in this problem, our independent variable, oh no. I think our independent variable would be all of the real numbers, meaning we can pick any number we want. And I think our dependent variables would only be the numbers 1 and 0. And this has got to be trying to get you guys ready for some sort of a programming language, because I've never seen a problem like this in Algebra 1. But I do get the feeling that that's what this book is trying to help us with, which is very important. So don't sweat that one too much. I do believe it is a function because it's consistent. If you look up any real rational number, if you look up any real number and it's rational, then your computer is going to spit you out a 1. This is called binary code right here. I mean, it's like the simplest form of it. And if you look up any real number and it's irrational, what are some irrational numbers? Well, they're numbers that cannot be written as a ratio or as a fraction. So those numbers do not repeat and they do not terminate. So that's like pi is an irrational number. E is an irrational number. So that's just a little look forward. Don't worry about it. The national debt with respect to time. Well, in this case, the debt would be a function dependent on the time. So the national debt is dependent on what year or what time of the year it is. And I think this is a function. If we looked up any time in history, we could calculate a unique national debt for that time. Not that we could actually calculate it because it's so dang big. But we could take a guess, and it doesn't even matter because money's not even real. Boom! Boom!